I'm getting a little bit more involved in 3D printing, or going to try to get more involved. First of all, to make proper fits, like the tolerances that you would use in machinery for the best results or best efforts from a certain machine, you need certain tolerances on that machine to actually achieve these results. And I bought some PETG, it's called. I'm not sure what the name is anymore. I did buy some PLA glow in the dark. I bought some Ninja Flex. It's a TPU. You can use it to make like rubber tires or anything rubber, even an O-ring for a seal for something, right? Because it's got certain properties and it's chemical tolerant to certain chemicals like oil and there's a couple of others. The brand's Ninja Flex, but it's doesn't print as fast as PLA because it's flexible, and your printer, when you're trying to feed in something flexible, it's going to kink and make a bird's nest in there, and it's not going to come out of the nozzle at all, right? Unless you have something that's on the other side of the feeder. You got to have a tube to make sure that it doesn't flex all over the place, right? And my Creality CR10 has these features, but I'm going to try to print with this material, right? I'd have lots of application for stuff like that. Oil seals, rubber tires. I have some old RC equipment lying around that I could make a remote control car out of it if I want, right? I can print one. Oh, and I got some carbon fiber. I think it's PLA based though. I'm getting different reviews on the subject. It's more rigid, but it's not as strength-wise and overall, regular PLA is better. And that carbon fiber is harder on a nozzle, so you got to get a hardened steel nozzle to make sure that it prints out correctly. But I'm going to try it anyways, and I'm going to try to create some tests to try to put it through its paces, right? And the same goes for everything else I bought. And I'm sort of really more wanting to know like the tolerances of this material. If I need like a thousandth of an inch plus or minus, will this material deliver? If you print 2 holes on a plate, and these are to guide 2 gears to make sure they mesh properly, what if that plate shrinks? What happens to the mesh between those gears? It doesn't mesh properly anymore. Unless you have these givens and you know how the material is going to react before you design it, right? So that's sort of my biggest curiosity on the material stuff, right? I know there's plenty of other channels out there that have put certain materials to pretty rigorous tests and got some good data on them. But it's kind of funny. You really have to work with the stuff first yourself to know what you're capable of printing with your machines. So without further ado, let's get started. I'm going to use these givens for my tolerance checks on this piece. tolerances between Fusion and the real thing, the real print, to see what my printer is actually capable of. And I'm going to be using, or the printer used these settings here, right? Amazon PLA 1.75 millimeter. Nozzle temperature is supposed to be printed at between 180 and 210. Well, Fusion 360 set it at 220 for some reason. It didn't give me a cooling fan for the printing stuff, and it heated the bed to 60. So Cura doesn't do that. Cura gave me perfect prints, but for some reason I can't get through to Cura through Fusion 360 anymore, so I don't know why that is. Even though it's a manufacturing code, my printer accepts it, but for some reason at the end of the print it sent the nozzle all the way up to 390. And normally my printer would have just stopped and hovered around on top of the print, right? Like a G54 or a G55 in the code. It's Marlin code, but it's still G code, right? So if you give it a G54 command, it's not going to try to hone at 0 all the time. It's a new 0 for the machine to stop at. So I'm going to measure the tolerances on that block with a micrometer and some telescopic gauges for the holes. And these were the tolerances. This hole over here is 1. That's 75. And 0.75, 0.5, and 0.25. And I've referenced this from this point here, this corner here, for to see if it stays within tolerances, right? If I put a hole here and a hole here, and I want to put gears in between that, what kind of tolerances is there? And will I be able to adjust that for proper mesh of the gears, right? Or do I have to find a way around that when I'm making gears? Like an adjustable idler or something. And these are the references from the holes from this datum here, A, so I can measure real values, right? So let's get started with this. Results you're looking for. This is my PETG filament. The settings are quite different from PLA. It seems to do well. Like it's not over, not finished printing yet, but the lines are very crisp now. I'll only know once I check the dimensions with the drawing, see if there's a big difference. But I did notice one thing though. The nozzle temperature is 240 and the bed's 80 compared to PLA. PLA has a 200 nozzle and a 60 bed. That's with the Cura settings. which seem to be doing quite well actually. The machine, I think the machine gave this thing 5 layers on either side and infill in the middle. Now, the Cura program lets you select between triangle, square, infill, and other types of infill. They have a library of settings, and these settings are for PLA, ABS, and some other stuff, and metal deposit. Metal deposit 3D printing. The filament is FFF, and the other stuff has another abbreviation for it. Oh, I just saw a strand. It left a string. The nozzle might be getting clogged or something. This is the a level on top of the infill. Now, it seems to be like I'm having bridging effect, right? Those are strands that hopefully you'll be able to build up the next layers. So this is the end of the print. And there are a few strings. You wouldn't get those with PLA, but overall there isn't anything that can't be cleaned or just picked off. Also, I don't know if you can see this. I guess there is a little bit of warping. The corners seem to be thinner than the center of this piece, right? This is the bottom side. See that corner? It seems to be of different dimensions. That was the underside. I think it may have printed too fast, right? If it printed too fast, it didn't have time to and those beads, look at the beads. Maybe that first layer should have had a print bed underneath, right? Or a support layer, a adhesion layer. This wouldn't have happened. This is my second time I print with PETG, and it's the same stuff they make water bottles with. I don't know if this stuff is recycled stuff. This is my first layer, and it's not it puts down a bead all right, but I don't know if you can see that right, but it's not, the corners ain't finished well like these, right? These produce a nice finish. I'll put a little chamfer on there, if you can, I don't know if you can tell. And when you stack up layers like that, here, this is where, when it was making its outer layers, I think I have set on 4. It'll make its 4 rings, but it always starts at this point. 1 ring, start, 2nd ring, start. And I think Cura will let you stagger these joints so it doesn't um, make a ridge, right? So if what I did was actually take these two, and since I made these right on size, that's a 1-inch hole, that's a 1-inch diameter, and for these one I want to make a loose fit, right? Not a press fit, but a loose fit. This would be considered a press fit, right? And this is not intended for copyright misuse or whatever. It's just instruction. Ordinary fit. Ordinary fit 4 to 5. Light push fit 0.2. And exact fit for bearings and stuff like that. So I made this, I think I made my loose fit at 4/1000 of an inch. These are the measurements from my CAD drawing, and these are the measurements that I coated my print with. A little info. Okay, so this is my zero tolerance piece. I get 25/34. And as far as height goes, see what the bottom layer is doing. $31.84. And my measurement gave me $31.75. Oh, and this one, which is this side, $31.84. See, I use this. It's called telescopic gauge, right? You insert that into the hole and you tighten this end to squeeze the dimension on there, right? And if I measure this now, $25.20. So the hole is $25.20. Here, $25.20. So even though I programmed this to be 25/4, the printer gives me this, which means there's some shrinkage in this material from warm to cold, right? And what you're hoping is that it's whatever you print may not be the dimensions you want, but the fits should be the same because the shrinkage of the material is the same. So if one wants this dimension and he knows the error that the material is going to create, he can oversize this when he prints it to get the final dimension to the right sizes, right? This is sort of why, I'm picking up this information, right? I'm going to make an Excel sheet to use this stuff. And this is Overture, I think. Overture Maker. So I have this and this. And now do it for this one, which is the exact size. No, this is the toleranced, or I provided spacing or fit. I purposefully made this hole larger by 0.2 millimeters. By 0.8. Six and 6. See, I got 6 over. No, they're both 25. I got 20. I got 0.2 over. Which this should not be. This is for not a loose fit, but a tight fit. This would be for a press fit. So what did I get for dimensions on this thing? I got 0 it. $25.34. All right. The height. $31.81. So 31-81. And now for this piece here, $25.25. 25.25. Okay. Now I want to know the dimension of the hole. So the dimensions on the loose fit, 25.59. That was pretty close to the printing specs. These still have errors in them, right? Because to really know what the printer can do, instead of using a 0.4 nozzle, you can use a 0.2 nozzle millimeters, but in doing so you double the time it's going to take to print. And if you do so, you wouldn't see these line patterns, right? And you wouldn't see these ribs, and you can even feel it. You wouldn't see these layers at all, but the print time would be, oh, astronomical. This is the beginning of the print for the PLA. As it always does, it makes an extrusion on the side to make sure the nozzle is clean and that he's got a good flow on the nozzle. Okay. Alright, so let's start with these. $25.34. Just a second. So, in keeping with the legend, I had now this one. $25.19 from this one, the one with a little dot in it. So $25.19. So now this one, $25.46. $25.34. $25.34. And measure this. $35. $38. $25.38. $34 here.